Everyone, this is Wolfgang. It's February 18, 2024, and we have more Solana updates. So I start with an overview of what is new with the Solana Labs client version 1.17, progress on another client, Zig, and an overview on the Solana transaction fee mechanisms. There is a lot of talk, a lot of discussions about it. We have covered it already, the last update, but I have some new points of view that I want to discuss. All right, let's start with the Labs client. In the new release, v1.17, that now most of the network is running, we have the activation of the ZK token proof program. This is a token extension and it enables confidential transfers using ZK proofs and homomorphic encryption. So you do operations directly on encrypted data and you can encrypt the token balances and basically not reveal the transfers except to the parties that you want to. In addition, there is this global auditor system mechanism, or anyway, it allows to embed in a token using this program or this extension to have compliance checks or auditing, basically allowing a third party to do these compliance checks. It is not needed and it's optional, so it's up to the program, up to the token issuer to decide when and how to use this system. Then in this release, we also have more syscalls for efficient computation of ZK-friendly hashing functions and elliptic curve operations, basically making ZK proofs easier, like requiring less compute units by having this kind of, let's say, precompiles. Then we have more efficient gossip message propagation. This improves network requirements and faster validator startup process. So that's it, and you will find more details in this link from the Helios blog, 0x Ichigo, to have more details on these improvements. Next, for this other client, Zig. If you don't know about it, this is another Solana client in development. So to have even better client diversification, we'll have not only the Labs client and Jito client and Ansa that basically are originated from the same source code in Rust. We'll have FireDancer in C and Zig in Zig. And this client is developed by Syndica, and their goal is to have a client optimized for reads. So this is good against slot lag. This is good in case of transaction spam. So it's good to have also this client optimized for reads, and we'll have also more diversification in terms of clients. So more languages. Less likelihood to have the same bug in more clients, so this is good. And the fact is, Zig is not ready yet, but it's in development, and you will find in their blog their progress on different parts of the client, on the different modules. So in this latest update, we have progress on AccountDB, and this is almost done, but they are in a stage of benchmarking versus the performance of the Labs client and see what other optimizations are needed. And regarding the gossip protocol implementation, this was already ready and implemented, but they're talking about further testing and refining. So this is good to see also progress for SIG. And we want to see more clients live on mainnet as soon as possible. Next, let's talk about the Solana transaction fee mechanisms. There have been a few very nice articles and overview research posts on Solana transaction fee mechanisms. So I will post the links in the thread. And but let's start from the basics. So we have to talk about base fee and priority fee. Every transaction in Solana requires a base fee that is calculated per signature. So there are 5,000 lamports or 5 microsol per signature. And most transactions have only one signature, so the fee will be fixed. And on top of that, optionally, you can add the priority fee. The priority fee is not fixed, but is proportional to the compute units, or better said, to the compute unit limit that you set. So when you send a transaction, you want to say, I will use at most this amount of compute units. And then you will need to pay depending on the compute units that you ask. Now, why would you want priority fees? For two reasons. Well, they come together, but yeah. The reason is to improve your likelihood or your probability to be included in the current block. Basically, you want your transaction to be executed as soon as possible. And this is expressed in two ways. One, you want to be executed in the current block. Two, you want to be ordered earlier in a block. So you want to be executed earlier because maybe you want to capture some economic opportunity. So that's why you would use priority fees. And it's not needed. I mean, it's optional. Right, then for both base fee and priority fees, you need to know that 50%, like half of it is burned, while the other half of the fee goes to the leader. And, the fact that you burn 50% of priority fee is not ideal, and it gives opportunity for other side channel payments, off-chain agreements. And this is something that will be addressed by a Solana improvement document, where basically there will be a mechanism to tip directly the leader and not having any burn. Other thing to know, there is a block limit, like there is a total amount of compute units that you can have in a block. There is 48 million compute units and 12 million compute units per account. And this is giving you some kind of parallelism or anyway local fee markets, in the sense that an account cannot be locked by operations that take more than 12 million compute units. So the rest must be used for other applications, or anyway, other accounts. Now, that's how it works, and the discussion moves to shortcomings or drawbacks or things that don't work yet as well as they should. So one is the idea of local fee markets, that, it's one of the strengths of Solana. The fact is that it's not really working yet ideally, like exactly as it should. It's not the end state. It will improve. And the other thing that we definitely need to talk about is the use of priority fees, because also priority fees are not ideal yet. So let's talk first about what are the issues here. There is a variability due to network jitter and randomized thread allocation by the scheduler. What I want to say here is that basically when you send a transaction, even if you have high priority fees, you cannot really be sure that this transaction will be executed as soon as possible, because there is some variability on how the transaction arrives to the leader, and this, at what time it arrives to a leader, and this is coming due to network jitter. And there is another source of variability coming from the fact that when a transaction arrives to a leader, then the scheduler of the leader will put the transaction in one of the different threads, one of the 4 threads dedicated to execution, pretty much randomly. So we have seen last time that there are plans to improve the scheduler, but today this is how it works. It's pretty much random, and depending on where it goes, it might be more or less favorable in terms of conflicts with other transactions. And basically, the time in which it will be executed, it's not really deterministically dependent on the priority fee. And there is another problem that makes feature anyway, that makes the priority fees less deterministic, and it's the fact that you have continuous block production. So it's not like you wait until the end of a block or a slot time to see all the transactions and then you order them by priority fees. That's not how it works. The block production is like a continuous stream. So it's really hard to give ordering prioritization guarantees to the users. On top of that, or in addition, in parallel, there's also a question on how do you know what is the right priority fee that you have to bid, basically. It's not that obvious, and especially not obvious for normal users, to estimate what is the right priority fee that will give you the guarantees to be ordered or be included as soon as possible. So at the end of the day, there is still an incentive to just spam and send many of the same transactions to increase your probability to be in the right thread, let's say, or to reach a leader earlier. So there is still that, and of course that's not ideal. Other issues or shortcomings, one is inefficient compute unit usage. And this is due to the fact that the base fees, as we've seen, don't depend on the compute units. So if you have one very complex transaction, but with only one signature, this will need a lot of compute units, so it will feel a big part of the block, but the cost in terms of base fee is exactly the same than a simple transfer of Solana tokens. And the other problem is the inefficient request of compute units, because there is no need to correctly evaluate the amount of compute units requested if you don't use priority fees. So when you send a transaction, normally one would expect that you should be incentivized to calculate and tell the network what is the maximum limit of compute units that you need, and that's it. You don't want to waste compute units. But here, if you don't use priority fees, there is no need to do this. And basically, you can request more compute units than what you actually need, because you don't want to calculate exactly how much you need. And if you don't use priority fees, the cost in base fee will be anyway the same. So that's also another thing that is not ideal. And another, the last in this list, is that today there is no cost on write lock accounts. So there is no fee for just asking a write lock. And this is a spam attack vector, because potentially you can just request write locks for accounts that you don't care about, and you can slow down the network for actual users and people who actually need those accounts. So that's, again, not ideal because it's costless. So let's move to the different proposals that have been suggested or anyway proposed to improve these issues or to solve these issues. And one that puts pretty much everyone in agreement, like, yes, we should do that, is having a dynamic base fee mechanism. So basically have the base fee, not just fixed cost per signature, but change this cost depending on the level of congestion of the network. So it's the other thing you should do is to have the base fee depending on compute units, but still it's not enough to just decide a price per compute units and that's fixed, because yes, that is solving the fact that more complex transactions should cost more, they take more block space, but it's still not enough, because how do you choose this number? So it's better to have some dynamic adjustment of this price per compute unit and adjust it depending on the level of congestion of the network or how much of the block space is used. It's good to notice that in this case it's nice to have fast block times, because you can react immediately to sudden spikes in demand. Then another proposal relates to, or a family of proposals relates to multidimensional account-based fee markets. So to achieve true local fee markets, it's not enough what we discussed before, that there are different execution threads and basically one account can lock at most one of these execution threads, 12 millions out of 48 millions, you can see it that way. But to have true local fee markets, you want to have more dimensions on the fees, and ideally have different levels of fees for different accounts. So every account will have its own fee market. And basically applications that are more in demand will become automatically more expensive without raising the prices for the other applications. Another proposal that is important to know is to introduce write lock fees. So make it really explicit that if you want to write lock a certain account and that account is in high demand, then you will increase the fees for that specific account. So this is SIMD 0110. And another proposal comes from, it's called PRO, Program Rebatable Account Write Fees. And this is also related to write lock fees, but it's much more, it gives more freedom to the application, to the account owner, to decide how to charge these fees. And so there is much higher customizability. And basically, those fees will go to the account owners. So imagine that There are failed transactions that right lock a state or an account because maybe they want to spam this account, because remember, today there are no right lock fees, so you could just do that. But in this case, the fees would go to the account owner, and then the account owner can decide what to do with it, and also have rebates for genuine users. So that's the pro, while SIMD 0110 is way less opinionated, or anyway, it gives less customizability to the user, to the applications, and it's just checking an exponential moving average of how much a certain account is using CUs, or anyway, the right lock transactions, how much CUs are using, because that tells you how much this account is in demand. And depending on this exponential moving average, then the fees will go up or down. So yeah, this is it. This is it for today. And these were the Solana updates. Thank you for following. And until next time, talk to you on Twitter. X. Ciao.